Good morning, everybody. All right, while we're waiting for everybody to come in, good morning, good morning. If you just came in, um, finish up your PowerPoint quiz questions. If you haven't done that, we're going to move on to analysis today. Okie dokie. All right, so take a few minutes if you have not turned in your questions on the PowerPoint from yesterday. Let's make sure that that is turned in first. So I'll give you about 10 minutes. Whoa, where'd my thing go? All right, if you've turned in your PowerPoint quiz questions from yesterday, go to Canvas and read over this section on DNA typing and analysis. And when I see Monday, we're going to have a quiz on what we've done so far as DNA profiling is concerned. So keep letting folks in. Remember, you're supposed to be on camera. Some of y'all are not on camera. But I will keep reminding you. All right, again, good morning. If you just came in, you are making sure that you've turned in your assignment from yesterday. Let me go to the home page for a second. Make sure everybody knows exactly what that is. All right, so if you weren't with us yesterday, we uh, went through this PowerPoint on DNA evidence, how it can be used to solve crimes. It had a quick review of what a DNA molecule is, what its structure is. Hopefully you remembered that from biology. And then some things that you can use DNA evidence to do. All right, we introduced the word CODIS, and we'll talk about that in the next two modules as well. And this is where your answering assignment started. You had to answer A, B, and C. You had to do the true false, and you had to do the quiz questions from the video. All right, so I'll give you another 10 minutes to complete that. And again, if you are finished with that, trying to go back to the module without going down that list. There you go. If you are finished with that, go to the Canvas section and read this one. I do have a video in queue for you to watch in just a few. All right, so this one is also, we also refer to this as DNA fingerprinting, which is different to fingerprinting, but we're also going to refer to this section as DNA fingerprinting. Okay. So please give that a read. 10 minutes, 10 minutes, 10 minutes, 10 minutes. So you're either turning in an assignment or reading. Yeah, your screen is totally black. I can't see anything. Looking at a lot of ceiling fans too. All right, so looks like almost everybody's here. So I'm going to stop sharing for a minute, do attendance, check y'all out on GoGuardian, make sure y'all are doing something that you're supposed to be doing. And then we will watch the video. And too many of y'all looking at me. Everybody should be in Canvas or trying to turn in that assignment on the PowerPoint, which is also in Canvas. One way or another, everybody should be in Canvas. That's how I know not to mark you absent. Hmm. Kayla, maybe you can adjust the lighting on your camera, maybe? Because it is just a total black screen. Xavier, you're logged in, but you're not doing anything. You're idle. Again, folks, we're going to try to stay on top of all of our assignments, be logged in and doing our work so that we're not falling behind, getting late submissions when time is allotted to you to get your work done in class. You should be using it. May not always be enough time, but it is time. All right, Brody, how you doing? My goodness. Yeah, yeah. All righty. Attendance is done. All right, take a break for a minute and give your focus to the video.
Hi, it's Mr. Anderson, and in this podcast, I'm going to talk about DNA fingerprinting. We sometimes refer to this as DNA profiling or your genetic fingerprint. And basically, it started with this guy, Alec Jeffreys. Basically, in his lab, he was working with X-ray and looking at DNA. And what he figured out is he could tell a lot about a person by looking at their DNA, quote unquote, fingerprint. In other words, he could see who they were related to or who they weren't. He could tell paternity, for example. And so he was working at the University of Leicester and basically figured out this whole idea of DNA fingerprinting. This is around 1984. And basically for the next 3 years, all DNA fingerprinting on the planet went through this university. And so eventually it was privatized, and this is everywhere. And it'll probably eventually be replaced by just DNA sequencing all the letters in DNA. But to make it understandable, essentially what we have in a human is we have long linear segments of DNA, but within that,
Uh-oh. My computer is glitching. Don't know why. My screen just went wide instead of small.
we have these genes. And so 99.9% of our DNA in everyone is going to be exactly the same. The genes are going to be the same, but again, you're going to have different copies or alleles of those genes. That's what makes you you. But if we look into this area in the middle, we used to call this junk DNA, but now we know it's really important in controlling gene expression. We find that there's quite a bit of variability in here, which shouldn't surprise us because the gene, makes the protein, and the protein makes the phenotype, and that's really what natural selection is selecting for or against. But this in the middle can go crazy, and so it does. And so an example of one that we use in DNA fingerprinting is something called short tandem repeats. Originally, we started with something called VNTR, variable number tandem repeats, and you'll find in DNA sequencing that you have all kinds of. So we had STRs, we have VNTRs. Before that, we had restriction, fragment length, polymorphisms, and so there's a bunch of different things that we could look at. But we've kind of moved to this idea of these short tandem repeats. They work great. There's quite a bit of variability in individuals. And so what is it? You basically have letters of DNA that repeat over and 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 over. So sometimes, 50 times it repeats. And so what does that look like? Well, if we have these three individuals, we'll call this Mr. Blonde, Mrs. Red, and then Mr. Mustache. And so if we look at these three people, their genes are going to be the same, but these STRs are going to be different. These single or short tandem repeats are going to be different. You can see that Mr. Blonde has more than Mr. Mustache and less than Mrs. Red. And so if I make that a little bit easier to grasp onto, if I count them out and then remove everything else, what we get is variability between all individuals. Everything else was the same, but we see variability in here. And we can cut these sections out using restriction enzymes, and then we can amplify them using polymerase chain reaction, and then we can separate them using gel electrophoresis. So how does that work? Basically, I'll take the DNA and I'll put them in a little well, and so we're looking down on this, and so this is a agarose gel. I could put Mrs. Red's and then Mr. Mustache. I could put those all in DNA. Basically, I would then turn on the voltage. So there's going to be a positive charge here, negative charge up here. DNA is a negative charge, and so it's going to be pulled towards the positive. And so what's going to happen is those little fragments of DNA are going to migrate. And so what does that allow me to do? It allows me to tell the difference between each of these individuals. And so this is their fingerprint. But you can tell that this is a really bad fingerprint because we've got these two are exactly the same here. And so when they really do DNA profiling, what they do is they generally use 13 different sections like this. And then those 13 sections are each going to be highly variable. So it's a good way to tell who's who. When would we ever want to do this? Forensics is one reason, and then also in maternity, figuring out who's dad. And so let's talk about the murder. There was a murder that was committed. Somebody was brutally murdered by one of these three suspects, so Mr. Blonde, Mrs. Red, or Mr. Mustache, but they left blood at the scene. And so what I can do is I can grab samples of DNA from each of our suspects, and then I could grab the blood itself, and then I could do DNA fingerprinting on them. So before we separate them, you may think to yourself, which of these looks guilty? Who looks like they're capable of murder? And if we separate them then using that gel, what we can see is that Mr. Blonde is guilty. In other words, his blood matches up with the crime scene. And so what do I mean by matching up? Well, those single or those short tandem repeats, if we look horizontally, are going to be exactly lined up. And if we were to look at Mr. Blonde's son, we'd find more similarities than we would between the others. And so basically that's DNA profiling, DNA fingerprinting. It's much more sophisticated than that, but again, it's kind of on its way out. We'll eventually replace this with DNA sequencing. In the US, the FBI has started creating this database of DNA, which is a little scary. And basically what they use are 13 different areas within the chromosome or the genome, and then they're looking at those short tandem repeats in there. Now, why do I say that's a little bit scary? I think you really want to protect your DNA, because as we learn more and more about genetics, what's going to be found in your DNA? Well, predisposition to Alzheimer's or breast cancer. Any of these things, which your insurance company would love to get a hold of. And so, and it also doesn't answer the idea of Mr. Blonde. Did he really do it? I mean, did the police frame him and then contaminate the blood? So we don't know that. All it does tell us is if we have two samples of DNA, the odds of two people having the same DNA fingerprint are astronomical, unless they're identical twins, but I digress. And I hope that's helpful.
All righty. So if you need to look at this one again, it is in your playlist. We're going to our in Canvas, if I can get Canvas to come back. So make sure that you are checking out your vocabulary. I think eventually I'm going to need a new computer because this one is slowly slowing down. Mm. All right, but I want you to go back to Canvas, which is what I'm trying to do. And make sure you read that page again. Notice he mentioned stuff like STR. He mentioned VNTR. So please take a look at those. I am going to ask you what those mean. Make sure you go through. Actually, let's look at this together. All right, so he's talked about DNA fingerprinting, and it's used to now analyze several ways of depending on the type of DNA found at the crime scene. Once DNA evidence is collected and analyzed, the DNA profile can be completed. Now, by a profile, they mean they set that this little page at the bottom here. That's a profile. Okay, it's not a picture of you, it's a picture of what your DNA looks like under the microscope after they've gone through the gel phoresis process. So you need to know what that is as well. All right, so then it says each person is, except for identical twins, will have a unique DNA profile, which is used in the context of CODIS. So the last page told you what CODIS was, and he told you what CODIS was. And it's actually just a database where they keep all this information so that when they come across something in one situation, they can compare it to something that they already have. Okay, or people that they already have, so they can tell maybe that you're related to somebody. I mean, maybe if they can't find you, they can find your relative and find out what your relative knows about the murder or the situation. Okay, so DNA profiling, and again, the profile is like a fingerprint in that the profile will be unique to just you. But he also mentioned that there are some similarities. In other words, everybody has eyes, everybody has ears. So some of your DNA and stuff will be coding for the things that everybody has. But then there are some things that are very unique about you. And those are the things that they are looking for in the profile. Okay. So like I said, he mentioned some of the strands of your DNA will be exactly the same because everybody has those characteristics, but a lot of the characteristics that you have are unique to you. That's how we can physically look at you and tell you from somebody else. All right, so then it goes through the process of explaining extracting the DNA and um, processing it through a polymerase. And um, so they give you a picture of the machinery that they're going to use. And looking at, remember, DNA is double-stranded and they're connected by hydrogen bonds. So what this is doing is it's separating it. So that's what this really is showing you. All right. And that's a picture at the bottom of the actual tub that when they said you're looking down at the gel phoresis plate, that's what you'd be looking down on. See that machine there? And then when you're finished, these are the results that you'll get after gel phoresis. And this is how they load it. All right, so go ahead and finish reading through this page. Um, and read this one as well. This one talks about CODIS. What CODIS is. All right, so I'm gonna let you read those, turn in the assignments that you have, and let me know if you have any questions. I will have a quiz on this on Monday. All right, so you need to know what is CODIS. It is Combined DNA Index System. Okay. It is a database. There are different levels of CODIS. And then we have our terms over here. So make sure that you know what a forensic profile is, a convicted offender profile, an arrestee profile, missing persons profile, unidentified human remains profile, biological relative DNA profile, forensics hit, offender hit. All right, so vocabulary. So I'm gonna check the grade book, see who's turning in what. I don't know why my screen went wide like this. Um, that's why. There we go. All right, so everybody should be doing something. You're reading, you're turning in your assignment, but I shouldn't see things that say idle. Like Brody, you've been idle for all the class. So Xavier, you too. Let's not be idle. Okay, I'm in the grade book, and then quite a few of you still owe the gizmo, as well as some of you, the same people, owe both the gizmo and the PowerPoint question. So please let's not get behind. All right, remember with the PowerPoint slides, you had to answer slides 6, 7, and 8. Brody, check your messages, because your grade message, because you did not do that. Um, hmm. Actually, let me see. Did I? Oh, y'all are very late. Okay. Not sure. Okay. All right. Those of you who came in late, we are making, there's two things on your to-do list. You make sure that you have turned in your Gizmo activity and your DNA evidence PowerPoint quiz. And you're reading DNA analysis in Canvas. You missed the video that we just watched. It's in the playlist on DNA fingerprinting. No. Yes, you can use the text box to just submit your answers. Yes. It is not necessary to send me the whole PowerPoint back. Just type your answers on in the text box and submit it that way. Or if you typed it on a Google slide, you can send that slide with your just your answers. Thank you. You're welcome. And folks, don't forget you had to do slides 6, 7, and 8. There are 3 questions on slide 6. You had to select the 3 statements that were true on slide 7 and answer the multiple choice on slide 8. All right, Kenzie, you know what to do. Okay, I'll check it. Oh, let me. And folks with the true false, keep in mind the question tells you that only three of them are true. So that means two of them are false. Okay. Okay, the PowerPoint, folks, was not that long an assignment. Everybody should have been finished with the PowerPoint. The Gizmo I might understand, but some of you were missing both the PowerPoint and the Gizmo activity. Again, we're not trying to fall behind. We're going forward. We're going forward. Like I said, next class, we're going to take a quiz on the reading. So make sure that you get to the reading as well as turn in your assignments. Thank you to those of you who turn in everything on time. Thank you, Adenia. And folks, the reason why you should correct your work or at least look at the corrections because they come up again on the test. So you want to make sure that you have correct information to study from. So thank you for your efforts in making sure that your work is correct. All right, so we're coming up on the last 5 minutes of class. Like I said, there's still quite a few of you who have turned in nothing. Oh, okay. Huh. All right, so this is almost like Friday, folks. So in the new grade book, some of y'all have a 0. Please correct that. You can just write true, false. You you can just number it 1 through 5 and say true, false, true, false, true, false, true, false. Or you can just give me the 3 that are true. Again, if you're looking at the PowerPoint, you slide 6, there's 3 answers on for that one. Slide 7, you want to pick the 3 that are true. And slide 8, you want to answer the correct answer on all 4 questions. Okay, folks, if time is run down, if you have no questions for me, uh, you are free to go. Again, make sure that those things that are missing, those of you who have missing things, are turned in because uh, updates on the grade book happen tomorrow, and some of y'all have zeros on for both assignments. Have a great weekend. Be safe.